Hey everyone, my name is Luczak-Roesch. I'm an associate professor within the School of Information Management, which is part of Victoria Business School. My research is concerned with mathematical models of complexity and emergence. So we want to understand unanticipated changes in systems that are so large that we can't measure individual parts to understand the macroscopic state of those systems. And what we do is we developed one particular method that captures coincidences, which are rare events that are unanticipated. And some of them are random noise and others have meaning, and we want to differentiate between the two. So how we do this is using a method called transcendental information cascades. And what that does is it takes any kind of input data that has some form of sequential order, so where we can take time points and they actually tell us something happened before and something happened after, so that's the sequential order, and turn it into a temporally ordered network. So networks, you probably know, are most familiar with social networks, such as this one. Networks are basically a visual but underlying a mathematical construct where we have nodes, so that are these bubbles that you can see here. And then between those nodes we have connections that we call edges. Okay, so and they tell us something about the relationships. And the transcendental information cascade method makes use of that because by using that we now have access to the entire analytical apparatus for networks and network analysis. So what we're doing here is, or what I'm presenting here is an interdisciplinary project of myself together with Dr. Grener, who's a lecturer in English. And what we've done is we've taken my method and we thought about, can we apply that to literature and actually make sense of literature using a very, very quantitative data-driven approach like this one, where we represent the literature as a sequential system basically and study structures that we can see there and then present that to students and scholars so that they can make sense of those. So we've taken that and we applied it to the novels of Charles Dickens, which is part of the research focus that Adam is looking at in his career. And we sliced all of those novels of Charles Dickens into chunks of 1,000 words, which is roughly one page at the time when they were published. So now we have every single novel as a sliced artifact where each slice is 1,000 words, and from those 1,000 words we extracted the characters, which is the named people that Charles Dickens refers to in his text. So when as he's writing, he's composing characters, they have names, and we extract those using natural language processing, and then we construct the transcendental information cascades. So let's have a look at that. So we have those dynamic network visualizations, and here's the first one of the Pick Papers, which is the first novel that Charles Dickens published. And in the visualization, we start the view to node 1 and 2, which is basically the first 1,000 words and the second 1,000 words, and there's a connection between the two. So in the first 1,000 words, if we click on it, we can see the details. So there's Augustus, Joe, Nathaniel, Samuel, and Tracy present in slice 1, which is the first 1,000 words. And then we check in the second 1,000 words, we see Augustus, Samuel, and Tracy present. So there's an edge between the two, but there's not everyone present, right? So you can then investigate who is actually responsible that there's a link. So it's because of Augustus, Samuel, and Tracy. And if we play that forward, we now get the third slice of 1,000 words. So first 1,000, second 1,000, third 1,000 words, and now there's more people present, which means someone wasn't present for 1,000 words, but is back, which is the reason why we have that edge over here. The interesting part of this is we can now hit the play button and see how the story actually evolves around those recurrences and co-occurrences of characters. And what you can see is sometimes you see those little flares where the story branches out and then dies off, which is very typical for the Pickwick Papers, which is basically the protagonist traveling with different groups of people to different places and shows the sequential structure of Charles Dickens' novel writing, actually. So again, we see one flare over here. Sometimes we also see bridges between slice 5 and 37. There is someone not being mentioned for 32,000 words. So when we want to investigate those artifacts, for example, someone not being mentioned for 32,000 words, we can zoom into that place and say, okay, that's slice 5, that's slice 37. Let's go to the content, where first find out who is it, who is not mentioned for 32,000 words. It's Alfred Jingle, and then let's go to the content at that particular place and deep read that part. So now we can actually blend our knowledge that we just achieved by looking at the network visualization with a deep reading of the text. And maybe we're familiar with the novel anyway, so that we can just refresh our understanding of what is the contextual story around that artifact where Alfred Jingle gets reintroduced after 32,000 words. From this network, we can create another one, which is a traditional social network. So now we again have nodes and edges between them, but a node is no longer 1,000 words. Now a node is a person. And we create an edge, so a link between two of those people, when they occur together in one of the 1,000 word slices. You wouldn't be surprised that Samuel Pickwick is obviously in the center, because Samuel Pickwick occurs with almost everyone, so that's not the most important part. The important parts are those communities on the edges, on the periphery of the network, because that basically means there are some people that are connected within their cluster, but they're not connected to many other people, and then there's other communities that are more interconnected. Over here we have Mr. Jenkins, who basically occurs only with Tom Smart, so he has only one connection into the network, which is interesting to understand the social world that Charles Dickens constructed. All of this based purely on an unsupervised approach where we extracted those character names using natural language processing. Another thing is we can now also look at this novel using the methods of information theory. So this is a graph that uses something called entropy, which is a measure of disorder or order. So basically describing how evenly are characters distributed as the story unfolds. And what we see is, we see those waves. Okay, we see this wave pattern in the entropy in the book Pickwick Papers. And what that means to us is, physics tells us entropy would usually increase up to a maximum equilibrium and then stay there in a system where no energy goes in or out. So what that tells us about this is a system where we have multiple equilibria, where it tends up there, it stays there for a while, it goes up again, stays there for a while. That means energy is injected at those points where it starts to increase again. What does it mean in terms of literature? Well, it means that there must be something going on about energy injection. Energy injection is actually he invents new characters. Okay, so this is a graph that shows you the first and last occurrence of a character. So if we go to Tracy Chapman, green means that's her first occurrence, red means that's the last occurrence. You see that green and red are all over the place. So that you get green all over the place, you get last occurrences all over the place. So it's quite distributed across the entire space of the book, and that is actually, every injection of a new character is an injection of energy. So where it becomes interesting is if you compare that to Our Mutual Friend. So that's the second to last novel that Charles Dickens wrote. And what we see here is a pattern where it increases up to equilibrium state, stays up there. Just by looking at the information theoretic measure, I can tell you it is a novel where everyone is known fairly at the beginning, and there should be a period where no energy is injected. If we look at the first and last character appearance, we see exactly that, because there's this channel where there's actually hardly anyone disappearing. We have two people showing up here in the end and disappearing immediately, but otherwise everyone's disappearing homogeneously in the end, and there's this channel where no one's introduced. So that's exactly what's responsible for this evolution of entropy compared to the one in the waves that we saw earlier. What can we take from this? Well, we could start interpreting this as Charles Dickens being more coherent with his character setup in his later career stages, where he was more experimental and ad hoc in his earlier career stages, because Pickwick Papers being his first novel. We can also look at all character appearances. So these are all characters in Our Mutual Friend, and then what we can do is we can start filtering for important characters. So let's move up and say everyone who appears at least 59 times, it leaves us with these characters. Okay, so these are the important characters in Our Mutual Friend. Or if we want to see it the other way around, we can reduce this and then just move the lever down here. So that's everyone who occurs at most 16 times. So that's basically characters that might be a bit peripheral. Some of them occur only once, like Mr. Grumpus. Others occur multiple times, and for them we're interested, do they occur in one cluster? No, they occur in two clusters, for example, and then individual times over there. So even those peripheral characters, some of them can play a role over the entire length of the novel. So all of that done through network visualization and information theoretic measures on a novel, so that we really turned novels into data. What I want to highlight here is still that this is an interdisciplinary collaboration. So even though we did all of this using computational tools, the main purpose of the project was to roll this tool into the classroom and see how English students interact with this. So we did a couple of user studies where students did exactly that kind of exercise that I just did to show you. And we looked at what do they confirm or come up with as new interpretations in terms of their understanding of the novel from the past. We've seen a few anecdotes where they confirm, for example, class orders, where you have upper and lower class interactions, or the absence of those, which is very, very well known for Charles Dickens' engagement with the social world of the 19th century. All right, that's from me. That's my data story. I hope you enjoyed it as much as we did developing this, and as we further developing this. You can test this application if you go to stia.shinyapps.io/TLIT. It's all open source. It's all using open access data from Project Gutenberg, so you can also get the code and run it on your own novels if you like. And we're always happy to answer questions about this. Thank you very much.